Here's CPM Calculus Chapter 2, number 38. So here we have a couple of questions. Is the inverse of an odd function also a function? Is the inverse also odd? How do you know? Include a statement to support your answer and sketch a graph of an example. Okay, so is the inverse of an odd function also a function? So what's an odd function? Odd function. Remember, if we place f of x, if we make the input negative, we get what? We get negative f of x. Okay, so simply what that's saying is, for example, x cubed, right? If y is equal to x cubed, well, we know at x equals negative x, we have y is equal to negative x cubed, and so it's odd, right? So for this example, we know it is odd, and also it has rotational symmetry in the sense that if you rotate this whole graph around 180 degrees, you're gonna produce exactly the same graph again. So if you just like turn your paper, rotate it so it's upside down, it's gonna be the same graph. Okay, so these are properties of odd functions. F of negative x is equal to negative f of x, and if you rotate it either 180 degrees left or 180 degrees right, you get the original function back again. Okay, so is the inverse of an odd function also a function? Okay, so we know we're starting with an odd function. What is the inverse of a function? Well, we know an inverse is basically we swap the x and the y, and then we solve for y. Okay, that's one way of thinking of it. Also, we know properties of inverse. Okay, swap x and y, solve for y, right? So another property of inverse functions is if you have a function, okay, let's say it is, I don't know, let's just say it's, I don't want to do an odd one first, so let's say it's y is equal to x squared. The inverse function is going to reflect across the line y is equal to x. So it's going to reflect across this. So if you had a mirror right here, this section is going to rotate across the mirror. This section is going to rotate across the mirror. And it's basically going to look like this, as the inverse function of f of x, so the inverse function in green. Okay? So it's going to reflect across this line here, all inverse functions. So is the inverse function of an odd function also a function? Okay, so what is a function? Well, a function we know passes our vertical line test. So if we have vertical lines here, we just scan it, or using our pencil, we scan it across, right? If it ever hits our function more than one time, we know it's not a function because it doesn't pass the vertical line test. Okay, that has to do with, for every x value, we could only have one y value. Okay, for every value in the domain, we can only have one value output. Okay, so it passes the pencil test, the vertical line test. So in this example, it passes. But what about the inverse? So the inverse, again, we're going to have to let me scroll to the right a little bit, give some space. So the inverse of that function, again, we're going to reflect it across this. So it's going to look like this and like this. So is this also a function? Yes, it is. If you give me lines, the vertical lines go all the way across, it's going to only intersect with our graph at one point, right? We're never going to hit it at more than one. So you kind of have to think, yes, it's a function, but can you think of any counterexample? Well, I guess you got to just kind of think about it, because I'm going to tell you now that it is not always a function. Okay, so let me give you an example. This function right here. So let's say it goes up and down and up and down and up. Okay, is this odd? Yes, if you rotate it, again, if you rotate it 160 degrees, 180, excuse me, 180 degrees, tell your paper's upside down, it's going to be exactly the same, right? If it's not exactly, that's what it's meant to be. Okay, so it's odd. Yes, odd. But is this, when you now take the inverse of this function, so reflect it across our y equals x line, is the inverse a function? So we know, let me go back to the question, is the inverse of an odd function also a function? So what's the inverse of this function? So the inverse is we're going to have to reflect it across. Okay. So this point was kind of hard for me, but right, something like that, and we want to reflect this across. Okay, so this is like our reflection. Okay, I'm not very good at reflecting across lines, but you can kind of see that this point goes from here, this point is from here, so it's the reflection across this line in the middle being our mirror. So is this function in red, or this relationship, like this new graph, a function? Well, if we take vertical lines, it's a function over here, right? It's not crossing more than one time when we have a vertical line, but here it's crossing more than once. Okay, even if I didn't draw it perfectly, we know that at many places it's crossing more than one time. So therefore, our answer for the first question is no. No. The inverse of an odd function is not always a function. The inverse, comma, the inverse of an odd function is not always a function. Okay, and we have an example, does not pass, does not pass the vertical line test. Right? This does not pass the vertical line test. And we even have an example where it does. So sometimes it is, sometimes it's not, and that's the answer for part 1. Okay. Part 2 is the inverse of an odd function also odd? Okay. So even if we took that last example, I'm going to go back to it and go to the right. So once we get what's in red, right, this is no longer a function, this in red here, but is it odd? If we rotate this around 180 degrees, so it's upside down, do we get the same red function again? And yes, we do. So actually, even though it's not a function, the inverse of an odd function is always odd too. So if we have an odd function, we take the inverse of it, it's also odd. Although it's not always a function, which we discussed in part 1. Okay? So include a statement to support your answer, which we did, and sketch a graph of an example, which we did. So this ends Chapter 2, number 38 of CPM Calculus.